This will be Bentley En-ROADS 8.7 in conditions, and I'll be conducting this. Today's agenda will include a definition of in conditions, a few more definitions of important parts to in conditions. I'll go over some basic in conditions. Then we'll get into some multiple target type design with variable slopes, sort of the real world stuff that we do on a daily basis. And then we'll get into dynamic in conditions, where the in conditions will change. I'll be using a retaining wall for this, and showing how we can make the wall taller and the footings grow in accordance to the height of the wall. And then we'll move on to roadway designer and show how we can put in conditions exceptions in. So if we're designing our road and run to an area where we want to need to make a change to our design, we can do this on the fly by implementing in condition exceptions. And then finally, we'll do some in conditions in non-corridor design situations. Probably going to look at doing a pond design right there. So a lot of different things we're going to be talking about. Now, this is a kind of a follow-up to the first part of this in conditions I did several months ago. And if you're on ETS, you'd be happy to go back and look at that and get a review. We're going to skip over, just cover real basically the basic in conditions, and hopefully get into a little more meat in this discussion, and also go into the roadway designer a little bit. So those will be some things that we didn't cover last time that we will touch on today. Okay, so what is an in condition? As you can see, it's a specialized components that are used to create design solutions. In conditions replace cut fill, material, and decision tables, and that's kind of why I wanted to talk about in conditions in non-corridor design situations, because a lot of these tools were used in non-corridor design or site type work there. In conditions are always open shape components, and we'll talk about that in just a minute as we start creating some in conditions, and we have the ability to do multiple target type options. So first of all, we'll define what targets are, and then we'll look at some in conditions that target not only surfaces but elevations and other things. So that's part of what we're going to cover today. A few more definitions. I said we would talk about target types, and here we are. Target type specifies the type of target that an in condition is seeking. So it doesn't have to be a surface. It can be an elevation. It can be a feature in the digital train model. It can be the XY feature, the XYZ feature, or just the Z feature. And then also we can target alignments, just the horizontal location of the alignment, which would be the XY, or just the alignment elevation, or the entire alignment. So a lot of different targets gives us a lot of flexibility in our design, which we need for designing in today's world. There's a thing in here, and we'll talk about that, called the in condition is infinite. Now we can say, just keep trying this segment until, forever. And forever is a very long time. But so we don't have to put in a 5,000-foot segment to make sure it ties into the existing ground. The in condition is infinite will allow us to do that. Another concept that we're going to cover today will be priority. And this tells us the order in which in conditions are going to be tried, okay? So we tell it, try this in condition first, and if that doesn't work, try this in condition. And so, we'll try to get a best case scenario design out of this by utilizing the priority. And there's some neat things we can do with priority. And my final definition for this morning is a rounding length. We have the ability to do slope rounding now, which is just kind of neat to do because it happens on a daily occurrence, and many agencies require that you do slope rounding. And so we can set up a rounding factor, and it'll round our slopes in so we get a true world condition for our design there. So, and we'll touch on that in just a second. So let's look at basic in conditions to begin with. This is going to be a simple design solution, and it's going to kind of be an introduction to in conditions, and we'll talk about priority and how that works. So let's jump over here into En-ROADS real quick, and we'll go ahead and load up a project, and that'll blast a bunch of information in there for me real quick. And what I want to talk about is going to be found here under the Modeler tab. Okay, the first thing we're going to do is go into Create Template. This is where we'll be adding our end conditions. Over here, I've got by loading that project, I load my sample ITL file. And the way I approach end conditions is I kind of put them in parts. Well, on templates in general, I put them in parts. Okay, so I've got a folder here called end condition parts where I can create things from the very beginning. And also, I'll take these parts and create total end conditions. So I've got a couple of things we can do there. So I'm going to right-click and say New Template, and we're just going to call this Sample to begin with. And so I have a sample folder, a sample template that we're going to use as an end condition. And I'm going to click on Dynamic Settings, and this gives me a little more precision when I'm out here placing things in my as I'm drawing my template. So I'm going to set the steps to 1 in both directions here. You can also set a slope and a direction there as you want to. Now I'm going to come over and right-click and say Add New Component, and you see the different type of components that are available to us in typical sections. What we're interested in this lecture is end conditions. So I'll hit End Conditions, and you'll notice down the bottom we have the opportunity to name the target and also assign a style to it. The style will determine how this thing is going to look, the symbology of the lines as they're drawn. So you can set that up if you want to. You also have the ability to set priority here, but we'll come back to this in a minute. But I'm going to start with just a real basic thing. I'm going to start here. I just click, and I come down, and I'm going to go to here, for example, and then I'm going to right-click and say Finished. And this is the basic, simplest end condition of all. So we can we'll come back over here to this point, and we will say Edit Point, and we'll just give this a name of ST for start there. And we'll put that in there. And then on the end right here, this is a fill slope. We're going to call this one fill right here. And then if we want to override the slope that we've got in here, we've got it set to a 3-to-1 slope. Let's go ahead and steepen that up to a 2-to-1 slope right there. And I mentioned the end condition is infinite. Now, if this was the only slope I was going to use for fill slopes, I would definitely need to go greater than 6 feet right here. So I'm going to go ahead and turn this end condition as infinite on, and this will allow us the ability to go well beyond a length of 6 feet when this is applied. So I'll go ahead and hit Apply right here, and you'll notice that the graphics are dynamic. As we make changes to it, the scales on this will change, and we'll kind of update for you. So kind of be aware that that's a dynamic thing there. I'm going to go ahead and just jump into the test for this real quick, and it's just I can put whatever slope line I want to in here. And this is a neat thing about the end conditions. If you draw them with decision tables, you kind of never know if it's going to work or not, where you can come out here and draw this and say, yes, it's going to work, and no matter where I go with it. Now, if I get above it, it doesn't work. We get a failure report over there, but we knew that wouldn't work. It's just a fill slope we're putting in here. So let's go back to our end condition, and I want to talk about the slope rounding, because that was something that we wanted to mention as well. And I've got a slope rounding. I can come down here to my slope rounding, and I can give it, I'll say, a length of 8 right there on my slope rounding. So just by clicking on the component and editing the component, I've changed the properties for that and set that up. So again, I'll come back here and test this, and when I draw this now, let me zoom out a little bit. You can see that I've got slope rounding going on for me. So this is doing this automatically for me. So this is kind of a neat thing that you can set up the length of slope rounding either on cut or fill situations and set that up. Now, I've talked about priority, and I'm going to come in here and I'm going to add another segment. So I'm going to right-click, I'm going to say New Component, and I'll say End Condition. And I'll come up here and I'll select a different style on this one. I'll make this one to be a cut section right here. And I'll start here, and I'll just kind of go up like this, and I'll finish that right there. And then I'll come in here, and we'll edit this, and we'll call this one cut as well. Now, I talked about priority, and when I defined this, I could have set the priority up when I just started it as new. But since I didn't do that, when I come over here to test, I'm going to give this message right here. It's going to tell me that the in-condition priorities conflict, and that's because both of them have the same priority. Both of them are set to 1 right now, and so it's going to give me the opportunity to correct this. So I'm going to go ahead and click OK to this, and now I'm going to go to the Check Priorities tab right here. So I'll highlight the Check Priorities tab, and then I'll hit Edit right here, and that will allow me to choose which one of these I want to look at first. Now, we're in a real simple situation. In just a minute, we're going to get a lot more complex, but I want to start out simple here. So do I want to check for fill first, or do I want to check for cut first? If I want to check for cut first, I'll leave that at a 1, and I'll change fill to a 2 right there, and we'll say OK to that. And now when I draw this, you can see everything's working just as we expected it to. So that's kind of a real brief explanation of in conditions, how you can create them, the priority and how it works. We showed a little slope rounding there. So like I said, this was just a real simple example of a basic in condition that doesn't really get into a whole lot of detail. What we're going to go to now is a multiple target design with variable slopes, and so we're kind of taking a great big step here. Okay, we're kind of going to put together an in condition for our best case scenario and what we want to happen. So this will be pretty interesting to see what goes on here. So let's jump back into inroads, and I'll create a new in condition right here, and I'll say a new template, and we'll call this, sorry about that, sample 2. And this time I'm going to kind of create this thing from parts. Okay, I've got different parts up here that I've created for, and this really makes it simple to put these things together. Now if I clicked on, for example, the left field right here, I've got a 6-to-1 slope for 8 feet. So that's what that definition is. And then I've got several more in here just like that. So I'm going to sample the active in condition. You can tell that by the red box around it. And then I'm going to come up here to my left field for 8 feet, 6-to-1 slope. I'm just going to drag it over and drop it in there. Okay, so I've added a fill slope there. So maybe that's what I want to happen first. I want to use a 6-to-1 slope, but if it goes greater than 8 feet, then, well, let's jump up here to a 3-to-1 slope for 16 feet. So I'll drag it in and drop that on top as well. And if it doesn't tie in on a 3-to-1 slope within 16 feet, then I'm going to come over here and I'm going to use a 2-to-1 slope, and this has an infinite in condition on it. So I can do this however I want to. So just for grins, now we didn't set up any priority on this, so when we go in to test this, we'll get that error message again. And so we'll go ahead and say check priorities. Again, we'll hit edit, and I want to use this 6-to-1 slope first, and I want to use the 3-to-1 slope second, so I'll make that the second priority, and then the 2-to-1 slope will be my third priority there, and I'll say OK to that. So now let's go ahead and test this. We're using the 2-to-1 slope. When we get in range, we're using the 3-to-1 slope, and then when we get in range again, we're using the 6-to-1 slope. Pretty simple stuff. Pretty simple, but pretty powerful in the same regards. Now, I've got a situation, that's still pretty basic. We're using 3 different slopes, but maybe I need a ditch in here. And I've got another part. I like parts, okay? This one's called ditch left, and this one just puts in a ditch. So just to kind of let you know what it does. So let me make sample 2 the active typical section again. And now I'm going to come in. I'm just going to drop in this ditch left here in case I need a ditch. So I'm going to come on here and I'll add it to there, and I'll come down here and I'll add it there, and finally I'll put it on my 2-to-1 slope there. Okay, so I've added some more sections to my typical section. All right, let's go ahead and test that just for grins. I'll go ahead and say draw, and over here and overwrite these, and we'll draw again. Okay, so now I see if it's sloping towards the embankment, I'm getting a ditch, just like I would want. But if we go back to that other slope where the slope was sloping away from it, I'm not getting anything. So, this is going to work great if I want to put a ditch in next to my embankment. But if I'm just in a regular field where it's draining away, this doesn't work at all. So, got to be aware when you're adding these things, what's happening with you there. So again, we'll go back and look at the 10% the other way, and you see nothing happening. So this is easy enough to fix. I've got a situation that works for draining towards my embankment. What I want to do is just come in and add another 3-to-1 slope on there, and I can make this a relatively short segment, but in the interest of time, and since I have these available to me, I'm just going to come over here and I'm going to take my 6-to-1 segment, and I'm going to drop it in right there, all right? And so this is going to give us multiple targets here. We can look up or look down. I'm going to come over here and take my 3-to-1 segment, and we'll drop it onto this point here, which was the end of our initial 3-to-1 slope. And finally, I'll come and select my 2-to-1 slope, and I'll drop it up here. Okay? So we'll probably have some priority problems here. So again, we can correct those as we're adding segments, or we can wait to get to this point to do it, and I think it's easier to check it here and fix it here. So let's check priorities, and I'll say OK to that. And what I want to look at first, do I want to look at the ditch section first, or do I want to look at the field section? I want to look at the ditch section first, so I'll make this one, the field section, a priority of 2. I'll hit edit on this one. Again, I want that to be the first, and so I'll make this one the second. And finally, we'll come over here to this, and I'm going to make this the second priority as well. Now that those are corrected, I'll say draw, and you can see that we're getting a nice fill slope now. Probably ought to change this down to about a 1%, so you can see that the 6-to-1 slope does actually work a little bit. Now if I change it to a negative slope there, I can go ahead and put that in there that way as well. Okay. So either way, real quickly, we've put together a complex template that's doing a lot for us there. Putting ditches in where we want it and not putting ditches in where we don't want it. It was really relatively easy. Okay, and this is just all based on our library of typical sections that we have and the parts that we put together pretty quickly. Okay. Now let's talk a little bit about dynamic end conditions. We did multiple targets design slopes with variable slopes, and we looked at 2 targets there with our multiple target design, and I think that can be pretty applicable to a lot of our work that we do today. So that's a solution that I know I've used on a few projects around. Now let's go ahead and talk about dynamic end conditions. And my best example of this is a wall section. Okay, wall footings, get larger or smaller proportionally to the height of walls. So if we can, lots of times, we're not trying to actually do the structural analysis for the walls here, but it's good to know where the footings are going to be. It can affect the right-of-way takes and things like that. So having the ability to resize your end conditions based on their height or things like that is pretty important. So let's come over here, and I'm going to just show you this this cantilever wall right here that we put together for the Georgia DOT benchmark that we did. This is based on their standards, and it takes a little time to put one of these together, a little more time than we have to dedicate to this session right here. But when we're looking at this, we can take a look at the constraints. Okay, so if we look at the constraints of a typical section, you can kind of see how the relationship to different points are. Now you'll notice that I've got a couple of slope constraints in here, and we'll talk about that in just a second. slope constraints, the footings are in a proportion to the height of the wall, which is a slope. And so we can set up a slope constraint to determine how far out the toe of the wall is in relationship to the top of the wall. And that's exactly what we did there. So let's go back, and sometimes the components are a little bit easier to look at. What I want to do is just click on this point right here and talk for a second about the constraints. This point right here is called wall foot top 1, so it's not real descriptive, but it is constrained by slope from the wall face 1, which is this point up here. And we tell it that it's at a 250% slope, and that's all based on how the footings are, get larger as the wall grows taller. And then vertically, we have it, constrained with another point out here, but that's not quite as important as the other. Now I've got another point over here, and again we're constraining the footings by slope again, and it's all based on the proportion to the top height of the wall. So that's how this works. Let's test this real quick, and we'll just come in here and draw this, and you can see as we go up and down with the surface how the wall actually interacts with where we draw it and how the footings grow bigger. Now that's kind of a real high-level look at dynamic end conditions. There are several end conditions that when you're constraints that you can use with when you're defining. So you can do a vector offset, which you can pick up points from your existing surface and things like that. You've got the slope that I just explained, and you've got horizontal and vertical minimum maximums. So there's several things you can do with typical sections, the end conditions in particular, that will allow us to get real good design results. What I want to do now is to actually take you into the roadway designer and show you how we can modify end conditions so that as you're going down the design of your road and you see problems in your road, you can kind of fix those on the fly. Okay, so that's what we're headed to now. So we'll close out of our template definitions now, and it's going to ask me if I want to save this, and I've just added some gobbledygook in there, so I'm going to say no. But we'll go to our modeler and our roadway designer. And I've got a road already defined in here, and I didn't really do a whole lot of design to this. I've got two typical sections in here, and that's all that's going on in here. So I'm going to go ahead and let this process all real quick, and it'll move down the road for us real easy. Now there's since I've looked at this project once before, there's a kind of a problem we could investigate down here at station 52. So if we get in this area, and for some reason the right-of-way agents have told, are having problems getting right-of-way here or something on the left side, so we've decided that we're going to go ahead and stick a wall in here. Now we could come back to our roadway definition and change that around, or we can just do an end condition exception on this. Okay, so that's what we're going to do. We're going to come into this area, in area of station 52, and then we're going to go up to, say, let's take a look at this. 57 looks good. So we'll go from about 52 to 57 and put an end condition in there. All right. So what I want to do is go to corridor, and I'll say end condition exceptions, and I'll go from I'll say 5175 to 5725 there, and we'll add that in there. Okay. Now we'll edit this, and this pulls up the section there. First thing I want to do is take out the existing end condition. So I'm going to right click, and I'm going to say delete components, and I'm just going to mark through that and take that out. Now I'm going to come over here to our end conditions, and I'm going to pick this Georgia cantilever wall in here, and I'm going to pull it over, and I'm going to stick it right there on the edge of the shoulder. Okay, so we'll fit this now, and take a look at that. And that's pretty much all I want to do. So I'm going to say OK to that, and I'll close this out. And as you notice now, as we walk through here, we're going to walk through, and if you look at the section here, the wall has been applied, and we can see, this is a dynamic scale on these cross sections, so it changes on the fly as well. So it's kind of hard to tell that the footing's actually getting bigger, but it is getting bigger as we walk through here. Okay. So a lot of neat stuff that we can do with in conditions and being able to update our design right there on the fly without having to add additional template drops and things like that. So a few other things I wanted to point out to you on the roadway modeler that have to do with in conditions. For example, let's window in. Let's make this full screen here and window in on this area here. Okay. So here we are on the right side. We've got no ditch there, and if I come down here and I pull this down to here, I do have a ditch on the section before this. So at station 8, I have a ditch, and then if we step forward to 8 plus 50, I don't have a ditch. These little red flags out here tell you that whether you have a transition going on or not, and so that's what those are flagging for you. So it gives you the ability to come in here and say, okay, look, I've got a ditch here. I don't have a ditch, I don't have a ditch, I do have a ditch. So, these are things that you would want to be aware of. Maybe there's a driveway there or something, so you need it like that. But maybe there's a condition on the ends that you need to come in and do an in condition exception. And this is going to happen just about any time you're doing a design. So that's just something I wanted to point out for you in our roadway designer there. Okay, in conditions in non-corridor design situations. There's lots of times where we have to do a little bit of site design things, either on the roadway or off the roadway. And so it's good to be aware of these tools and how you can utilize them in non-corridor design situations as well. So what I'm planning on doing for you is actually designing a pond for us. And we're going to, I've got these graphics drawn out here. The red line represents the bottom of a pond, okay? And what we're going to do is take that up to a certain elevation that we'll define, and we will put in a berm and excavate or fill as we need to create this pond, okay? So that's kind of what's going on there. Let's, just for your benefit, we'll turn on a reference file. We'll add some topo in there, and so you can kind of tell what's going on with the existing ground underneath there. Now, back over here under our modeler, under Create Template, I have another section over here which I call Site Design. And this one I just have one typical section in here. And it's kind of funny, I created this one without using parts, and when I tested it, it tested all. So that was kind of interesting that I got no results when I tested it, but it does work. Just take a look at this section and talk about it for a second. I'm going to come in here and we'll just edit this component. And here's where we're telling it to seek an elevation of 932. Okay? So we're telling it the target type is an elevation, and then the elevation that we're seeking is elevation 932. So if I take this to another project and try to utilize this, I need to be aware that this is where I will set the target elevation. So naturally, I won't always have the same top of pond elevation. So just wanted you to be aware of that. So it comes to here. This point right here is an infinite in condition. I've got a 2-to-1 slope on it, and so it'll go as far as it needs to reach elevation 932. Okay. After it succeeds there, the next target that we'll see right here is a design surface. Okay, and so it's going to target the existing surface or the active surface to try to tie in, and that's pretty much how this works. There's not a whole lot to it. We used to do a lot of this with decision tables, but these are so far and above that we needed to explore these today as well. So I'll go ahead and close this, and we'll come over here to our graphics that I already have drawn, and I'm going to begin with having the right lock turned off, and we'll go ahead and start. We'll go to Surface, Design Surface, and then Apply Template. And even though it says Apply Template, really it is an end condition because we're trying to tie in to a surface. We'll create a new surface called Pond. In the beginning, though, we're going to just generate graphics here. So we're going to just generate graphics, and then we'll come over here and we will pick the section that we want to use. Now, these two buttons up here allow us to do, either if we mirror, we can do both sides. If we reflect, we can do it the opposite way. And this is pretty important to realize, and you'll understand that a little more clearly after I do this the first time. The direction in which you draw your graphics sets the stationing on that, okay? So I'm going to say Apply, and then I will identify the primary, which will be this, and I'll identify the reference, which will be this, and now it's going to ask me to reset for the entire surface, so I'll reset. Now, this went to the inside, so this was not what I wanted to happen, but it's not a heartache. I don't have to go back and rewrite the whole typical section here. I can simply come in here and say reflect on this, and we'll do this one more time. I'll say Apply, we'll pick it again, and this time it goes in the correct direction. Okay. So finally, one more time, I'm going to turn off Generate Graphics Only. I'm going to actually write the graphics to my drawing by turning on the right lock, and I'm going to have it put in this surface called Pond right here. So we'll clean that up. We'll say Apply. We'll pick it one more time. We'll pick it again. We'll right-click, and now we have some information in the surface called Pond. If I go to View Surface Contours, and we'll put this down here at about 1 foot interval there, we can blast that in, except for we picked the wrong surface. Okay, we'll let that go ahead and finish there. We wanted to do the pond surface right there, and we'll load up a proposed preference and blast that in there real quick. So now you can see we've got a pond going on there. And finally, we'll do a profile through the pond. We'll create a profile. The source will be multi-point, and we will use pond and say Apply, and we'll just go from there to there and zoom out twice and put a profile there. So that's pretty much what you would expect that to look like. And one thing I kind of wanted to point out to this, you'll notice here that the slope is sort of rounding. I added slope rounding to this end condition to kind of let you see how it would kind of come out there. And so a lot of good stuff we can do with the slope rounding and things like that. So in summary, end conditions are some of the most powerful tools that we've added to En-ROADS 8.7, and we can do things now that we've never been able to do before, and we've got some solutions that are just fantastic. We can utilize multiple target types. We can have dynamic end conditions which grow larger or smaller as we need them to do, and it gives us the ultimate in design and modeling capability, more so than we've ever had to date. So this is a great enhancement, and I encourage all of you to dive into these end conditions and try to utilize these. And I think you'll find them very powerful, and you'll be very successful with those. This concludes today's session on end conditions, En-ROADS 8.7, Part 2. Thank you.